Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
This is a nice little real-world example that gives us a mass spectrometer where we have germanium atoms with radii of curvature in a magnetic field of different values. So I won't draw them all here, but this is just a schematic for what we're looking at physically. And the different radii are r equals 21 centimeters, r equals 21.6 centimeters, r equals 21.9 centimeters, and finally r equals 22.8 centimeters. And we know that the largest radius corresponds to an atomic mass of 76 U, so atomic mass units. And we want to know the atomic masses of all the other isotopes. So this really isn't something that's too tricky to figure out, because we know that the force, which I'll write over here, QVB, is equal to the centripetal, the force from the centripetal acceleration due to this circular motion. So this equivalency is going to let us get an expression for the mass, which is QBR all on V, which is the velocity. But we can actually get this in terms of a mass ratio, which is going to simplify things. So if you write m over r is equal to q times b over v, which is the velocity, this is actually a constant. So q is the atomic charge, which depends on the number of protons, which, since it's germanium, they all have the same number of protons, so that's constant. The magnetic field is constant. And finally, the velocity is always going to be assumed to be constant as well, because its acceleration depends on that q. Thus, we just need a mass ratio, and that will always be the same. So we have a mass ratio over here, and it is 76 U over 22.8 centimeters. All right, those were things that are all given, but the same, let's write these 1, 2, 3, 4. The fact that this is a constant lets us say now m3 over r3 is going to be equal to m4 over r4. So radius 3 is 21.9 centimeters. And then it's all a matter of solving for m3, which m3 in this case is 73 U. And you do the same procedure each time. So I'm not going to do it explicitly for these, but give it a try and see if you can correctly solve for the ratio. So you're just going to move this over to that side, and then you have an expression for m3. And finally, m1 is equal to 70 U. So it seems daunting because we have an experimental system, but in the end, it all worked out to a very simple constant ratio. Now this was the key, the fact that that is constant.